back. Look at this. We're spinning aluminum with eddy currents. Check it out. It's a nice, simple little kind of gear ratio there. It's the same. The aluminum disc is the same size as the two rotors right behind him. Same size, so it'll interact kind of the same way. We're at 0.39 of a volt going into the system over here. So that's less than what, 0.3 of a watt or 0.03 of a watt?
Let's see.
Less than a tenth.
So 0.01. So. Oh wait. Way less. Yeah, less than a tenth.
And it's moving pretty good, man. We get our tach. There it is. Excuse me, sir.
Yeah.
Alright. I'm willing to bet it's going about 60. We'll see, maybe less. 52.8. You know what? I was just saying that we're getting on a little later than usual, but I think that's going to be good. What we have to show everybody and ask questions about. It's supposed to be an axial flux coil for pushing this aluminum disc over here. You can do it with the permanent magnets on this rotor, north-south magnets. You can spin it pretty fast just doing that. But I think this is going to be cool. I need to make 4 more of these. And then arrange them kind of like the Olympic rings. But like overlapping each other completely instead of like below and above. Just directly over each other. And that'll be like the spread that the coil needs to be in for it to work right. And then you need it to be hooked up parallel so that you can control each coil, the polarity of each coil. Kind of how to do that, I have no idea, but I kind of get how it works. Just had to back it out a little bit because it's sliding down the pole.
Yeah, I saw that.
And see it go the other way. If you just spin it the other way. It's like proof of concept right there. I've been dying to do that. I finally got a north-south rotor that I thought was good to do it with. Couldn't make this one north-south because those magnets are mean. They're straight up mean magnets. You get them too close together the wrong way, and they like to pinch you.
too.
Alright, so I had a question about this coil. I got a 26 gauge wire and 22 gauge wire. This is a 22 gauge version of the coil. Because it's supposed to be a high frequency gig, so I'm thinking that the thicker the wire, the better that'll end up being. But I don't know, like, could it be Litz wire? That's what I was wondering. Instead of just the solid single gauge wire, have it be Litz wire. I think that would be best, actually. I was looking at the specs for the Litz wire, and it can handle up to 100 kilohertz. Yeah, so I mean, I want to see if the motor can end up spinning that thing really fast. In order to do that, I just need to back this up and unclip these from this motor because everything's kind of hooked up to the same power supply. And turn this up. It's about 15. 15 volts.
Yeah, and it uses it pretty quick.
So there's obviously with the aluminum rotor, there's definitely like a load that is too much. And then when I have the other rotors, the other 6-inch discs, they'll help each other out, man. They'll help each other spin. Not faster, but in sync with one another. So
That's right. Yeah.
so if you want to let's back this out. I know that's not a good idea, but I just want to see. This is a north-south rotor, and this coil will spin it.
Oh yeah, the other way.
It's having trouble with the north-south and whatever load that the aluminum disc is putting on it together is not letting it go. Just saying that it works.
Yeah.
Works really good with the north-south. But when it has that added load on it, and because it's north-south, it won't work. But if it was monopolar with the load, it would work, I would think.
Yeah.
But it wouldn't be pushing the aluminum disc like it is because monopolar, if you have the alternating thing, then it's going to work better. Look at it move, man. It's north-south. But there's no way you, I mean, maybe if I moved it in there now. See, and that's only 0.5, 0.6, and that's humming.
You want to be over here?
Maybe. Let me see what I'm looking like over there.
Anywhere where you're comfortable, for sure. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale.
Hey, what's up, everybody?
Drop us a like and subscribe. Let us know if you got any questions.
I don't want it to stop, though. That's the thing.
There's a sweet spot. Let me see if I can get a tech read on that.
Nope, that was just a stand.
Okay.
Wow, it is pretty, it's whipping pretty good. But it's pushed all the way back to the...
Oh, it's move. I got it.
It was pushed up against this and grinding against that.
Got it. Oops.
You can hear that load on the rotor, though.
Mm-hmm.
So is it spinning pretty fast?
Yeah.
I can't really tell from this angle. I'm assuming it is.
That's right. It didn't stop the rotor.
Awesome. It's still spinning. That's pretty far back, or is it spinning from when I had it up close? I don't know. But it's still going.
Still going.
And I'm not holding it, and that makes me feel good. Ah, that's awesome. Okay, turn it down. We all know what that is, right?
That's the core.
Yeah. The core got sucked in. It's all because it's getting hot.
Okay.
It's not really hot, it's just getting warm enough for the tape to get soft.
Right, and then enough. Yep. All right.
But that, see, without all the extra load, it runs really, really, really well. And then with the little load, it runs good too. But with a lot of load. Whoa, you need to get a shirt on.
Look at that. That is sweet.
Heck yeah. And I'm just dreaming in my head about, like, if I actually got these to go north-south. But I'm not even gonna try. Not even gonna try. That's not gonna happen. Hey. But with these magnets and this configuration on that disc, it would be whipping, like whipping. So we had a catastrophic failure the other day, and we're still kind of recoiling from that. I had a capacitor kind of blow up in my face, and then I like had to touch my face.
Make sure it was still there.
Make sure my face was still there. Anyway, I haven't touched a capacitor since then. That's what I'm talking about, man. This stuff is not a joke. Yeah, I'm not. Yeah. Well, I mean, this stuff is great. You know, I'm pushing aluminum with permanent magnets, man. I mean, it doesn't really get much better than that. There's no. I mean, to get it going really fast, you need some electricity, but you know, it'll work.
So what is this called again? What's making it move?
The eddy currents in the aluminum.
That's right. And then it does put a load on the rotor. So no, there's nothing like that. Nice.
Yeah, it's really neat. Yeah, there's a price tag on it.
You're getting
I get a lot of use. For every $100 that I spend, I've gotten like 200 videos worth of material out of it.
nice.
And the way I do videos is every experiment, pretty much. I'm starting to group them together, if it makes sense to group the experiments together. But every single video is different in its own way. And every single video is dedicated to a different thing that I wanted to check out, and it's bad though, because I don't know what any of this stuff is called. You know, I don't, you know, the thing and the place, you got there on time, but you know, the thing,
Mm-hmm.
right. I've been just starting to work with the SG circuit. I did a little while back, like 6 months ago. I worked with SG like once, and I honestly, I guess it must have been the way I set it up, but it seemed really wishy-washy on whether it was going to work or not. Like the light wouldn't go on all the time, or you know, something wasn't right. Either my transistor was blown, or you know, something wasn't right. And then I just got back into it a little bit about a month ago.
Mm-hmm.
I got bigger transistors. I can just hook up the whole circuit on the transistor. Don't need anything else. I mean, just a few clips, the Schottky diode, rectifier diode, the resistor, and the light, the neon light bulb that is about a 90 volt variant, 90 to 100 volt light bulb. It's real simple. Like once you know the direction, even if you get the direction wrong on the diode, you flip it and then everything will work. And it won't break it. It won't break it. I've done it, so I know it won't break it. Doing it wrong won't break it. Because it's just a Schottky diode that I always had problems with. Like, which way does it go? Base to emitter. But it was weird because I don't know. It's very strange. Um, I've had some extraordinary experiences doing this where I'm supposed to get one thing and I get a different thing, and the only thing that I can think of is that there's a different variation in the coil.
Yeah.
There's either wound differently because you're getting a different signature. Every single one of my coils is different. You know, it has its own soul. It's one of my babies. You know what I'm saying?
Yeah.
And there's been some doozies, man. They're my babies, but there's been some doozies. I gotta let you know, man. It's just, whoo! Maybe I shouldn't have done that. Kind of doozy, you know? And it's really terrible to say that about, and I'm not saying that about my kids. No, absolutely not. My kids are great. I don't deserve my kids. They're that good. Uh, and you know, I feel very blessed to have them as my offspring. Very cool. All right, so I really just want to turn a freaking motor on, dude. That's what I want to do because I'm sick and tired of spinning that thing with my finger. And I think we got to back it out first.
Okay. Oh, I could have. Sorry. Yeah, I could have done that. Oh, yeah, I can feel that.
So it's triggered,
Yeah, you can hear it.
and now the coil is that it's been triggered is now sensing. It's now there it goes. I'm gonna move it in a little bit more. I think that's good. Wow, dude, I never got a look at it from this side. That's going pretty good.
Yeah, it is. Wow.
Yeah, you can't even see that piece of tape on the side.
I know, it's going so fast.
It's giving me lots of ideas. You know, and if I moved, well, nothing will happen because I unclipped them. But at 16.6 and zero point 0.6 amps, if I were to move this switch into play over here, I would start a fire.
Mhm.
The arc would be that hot. It would just,
Right.
and that big. I mean, it would just be, because it's 16 times 3.
Mhm.
And then the amps, whatever is going through here, I have no idea really right now. Hell yeah.
Feels like it's speeding up.
Speeding up?
Probably not. I'm just kind of feeling it.
Here, let's move it in a little bit. That's awesome. is freaking cool. And Blue Star gave me the idea for this because he had the little magnet, Newman motor magnet, basically, with the north and just one magnet, north south. And you spun it and you rotated it and removed the aluminum disc. So I'm like, well, why don't we just, cut it open and stretch it out and put it on a wheel? Duplicate it, it's just a pattern, north-south. And duplicate it and put it around, and then that's just what I saw. And I'm like, wow, and it really works.
Oh, I'm shaking. I don't know.
All right, pull back. That's cool. It is kind of hard to just hold there.
Oops, sorry about that, folks.
So that's good. Take a look at it. See how fast it's still spinning. It's going to roll right off the edge, though. So I'm going to grab it.
I think it's when it stops. Or no, I think
It's continuously coming this way as it spins.
Yeah, it is.
No, it looks like it's stopped, though, because
Momentum.
it's kind of just not moving every rotation.
Nice. And then that thing's flying.
Yeah, look at that. Wow, where's the tach meter? I want to see how fast that's going. With my one bifilar coil. It's only got 1,000 turns in it. 786, 803, 810, 814, 821. Wow. 831. 842. I think since we backed the aluminum rotor out, it's had the opportunity to pick up pace again.
Yeah.
What's free energy? This is definitely not free.
Right.
865. 870. Wow. People getting anxious.
Finger.
So I'm going to turn it down to 12 volts. See if that helps at all. 822.
All right.
818.
Yeah.
814. Yeah, that helped a little bit.
Hey everybody, welcome to the channel. Thanks for dropping in this evening. This is Papa Bale, and we are working with pulse motors and eddy currents spinning this aluminum rotor.
See, the first thing you're going to notice about this table are there are no batteries on it anywhere. I have two power supplies over here, but they're plugged into the wall. Okay, so am I wasting? I wouldn't say I'm wasting it. I'd say I'm using it. I pay for it. Right now, that's what matters. In the future, it'll be different. But right now, you got to pay for it and you can use it. That's what I'm doing. And in the future, they're going to give it to us because it's going to be so abundant. They're going to take care of us in the future. Or they should. First you gotta get rid of a lot of things, man. Lots of things have to change. But that would be great, part of a better world is having the first 4 layers of Maslow's hierarchy pyramid taken care of for you by robots, basically.
No, that's more of a zero marginal cost argument.
Yeah, zero marginal cost, abundance. So like this coil right here is going to be an axial flux coil, probably for this rotor even, right down here. Like so. I don't know if it's, I might have to do something else with it.
Mm-hmm.
I'm just going to nip it in the bud before it happens.
Nice.
Alright. So the setup requires that I build 4 more of these. 3 go on the bottom and then 2 go on the top. Kind of like a chain link. Yeah, I'm thinking. I'm good.
Kind of like a chain link. How are you gonna build the? How are you gonna make them link?
You just lay them on top of each other, bro. The thought was over.
Okay.
I'm done with that one. It's like, you're like, keep going. I'm like, there's nothing else. 764, 765. And that's at 12 volts. I think that's pretty good for that one coil. It's a tiny coil, man. 26 gauge drive, 30 gauge trigger and sensor coil, and I think it's 911 turns. I'm pretty sure it's 911 turns.
Nice. In the little core. It's the core.
So what you do is you take your spool, a 26 gauge, and you take your spool, a 30 gauge from the start,
Mm-hmm.
okay? And then you wrap them however many turns you desire at the same rate, same speed, one on top of one another, uniformly across your coil. Now, when you get to, I usually start on the left, and I wrap counterclockwise. So I start on the left, and then I do a uniform layer all the way to the right, and then I go 2 turns back to the left. Instead of doing an entire uniform layer back to the left, I just do 2 turns back to the left, and then I do a uniform layer back to the right. So, boom, boom, that's how I wrap them. And I believe that's repulsion wrap, and then you go uniform layer to the right, and then uniform layer back to the left is traction.
Okay.
They're both good. I mean, they both work. They're both good. I do understand how having like all of the coil not being confused as to what's north and south is important. And the law here in my hand. No,
Sure. I can't see it.
well, you got to move. Uh, See, this is the way it goes.
I got it. I got it. So the winding of the coils.
Will tell you which way is north and which way is south.
Got it. And this is the input now, meaning that's the cost.
Yeah.
There you go.
All right. So yeah, I want to do some low energy experiments real quick. You know, I love the homemade reed switch because it gives me the opportunity to run parallel circuits through it on a reed switch. Man, that's like unheard of. You're gonna blow your reed switch out, you know, and any kind of reed switch, you're gonna blow it out, except, you know, one that's made out of copper. Let alone a parallel circuit of 20 gauge drive coils. Awesome. I think it's gonna stay where it is.
Mm-hmm.
Nope.
Nope.
Dang. All right, we gotta readjust now. Shoot.
Yeah, pull. Yep, you got it.
It's kind of in the middle of the sweet spot.
Mm.
There it goes. Oh, we're drawing 100 milliamps at 0.6 volts. We're generating about 5 volts of AC on this coil right here. Now in between 6 and 7.
Hey, Noah, what's up?
What's up, Noah? So we're getting times 10 right now. I think it's times 10. Yeah, 0.6 in, and we're getting 6 out.
We got the eddy currents to spin the aluminum rotor earlier in the stream. Pretty sweet.
And I can hook that back up in a heartbeat, but it was falling apart basically on the screen, so I just didn't want to hold it. It's not because I'm lazy, it's because I gotta move around, there's other stuff I want to do. Can't just be holding the legs of that thing all night. We get rolling, man, I'll pay somebody to do it.
Mm-hmm.
Be like, hey man, here's $20, just hold this. Screw it, man, here's $100. Just hold this. Inflation, man, it's crazy.
Hey Raphael, welcome to the channel.
How's it going? Awesome. So there's our input, man. That's no joke. That's real. And here's our output. This is the kinetic output, and then the voltage output is on the meter over there. So that's a times 10 ratio. It's a 12 magnet rotor. So it's not the most efficient rotor, but I mean, I like it.
Mm-hmm.
And for a reed switch to hit every time on a 12 magnet rotor, when it's that like that, is pretty awesome. It's like it doesn't happen very often. Usually the magnetic force is too close for my reed switches to be able to react. It's like it overlaps kind of.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale, and we are working with some low voltage experiments right now. Drop us a like and subscribe. Let us know if you got any comments or questions about any of the builds or anything we're doing.
Now we're up to basically 3/4 of the volt. And we're still at basically times 10. We're now at 7 volts. Let's get a tach reading on this. Where's my tach meter go? You got it. Thank you, sir. Instead of just looking at it, we'll give it 91. 92, 91, basically 90. That's slow. But you know, this is not a high frequency switch, so it doesn't like pulse very, very quickly. Even when you put a bunch of volts into it, it doesn't pulse very fast. But in order for it to work, you don't have to put much into it at all, like barely anything. And I'm working on a more high frequency switch that is like this, that is not vacuum tube closed. It's virtually just this and like a paper clip.
Yeah.
But I need this top part here to be longer, like as long as the wire is right there. And then put it on there like that and have it be longer. So that's what I need. I could print that out. Just need a little longer bit of a plastic piece. Really, it's got to be about that big. This gray part right here.
Yeah.
It's got to be about that size.
Mm-hmm.
I could even use this right here, right now, but I don't want to waste this thing. It's pretty cool. 1, 2, 3. Yeah, 1, 2, 3.
Nice. It was there. It's there now. Yeah.
See, but now we're losing ground here. Now it's well,
No, I see. Not 10x.
it's not 10x anymore. See, that's what I mean by the frequency. You can put the voltage in, but the frequency of the switch is not going to allow. Yeah, the frequency of the switch is not going to allow that 10x to proportionately increase.
Yep.
But you get to start way below what most motors even get to think of starting at.
Upper 8.
Got 1.11.
Oh, no way. You did.
I landed right on it. And
Look at that.
that's one way to do it, land right on it.
It's really hard to do that.
Yeah. Now I'm going to go to 2.2. See, but now we're drawing like 200 milliamps. Oh, 100, cool. It's a steady 100. It's not really like fluctuating that much. We're at 11 volts.
Oh, he said, can you go lower in voltage?
Lower in voltage? Like how low? I can go to 0.3. Actually, you know what? We gotta stop it.
Look at this, guys. I got an ankle biter. Oh, oh. Catnip.
0.31. We're seeing it's closed right now. The switch is closed.
There we go.
Wasn't a good spot.
Yeah, go ahead and find a spot and let's see if you can go below.
No, you can't. You can go to like 0.18, but it won't work.
Okay.
Once you go below 0.18, it'll go to 0. Point 2. Man, we'll see what happens at 0.2. It's working. really don't want to hold this thing.
Alright, see if it'll do it.
Alright, point two.
He's like, I bet it'll spin at 0.1. I think we got a 0.18 cutoff.
Yeah, it won't spin at point one. I'll put it down as far as I can. Maybe it will. Maybe it will. Let's see. Because now I'm nudging it and it's not going. So I figure that the next time that it wants to go, it's going to go to 0.
Ooh.
Oh! It stopped. Let's see if the motor keeps going. 0.13, ladies and gentlemen, this is a first for me. And I'd like to fancy this because of the solid connection that you have from a switch like this. Yeah, but I can't hold it straight.
Right. We gotta get it glued in. I might be able to hold it in position.
Oh, no. I got it right now.
Alright. Have you gotten a pulse from above or below? Oh yeah, you've arranged coils, so you not just doing it from the side.
Which one? Oh, you mean
Oh no, that's right. If they're vertical, yeah, my bad. So yeah,
it's basically the same deal. It's just you flip it on its other axis.
more.
A lot more. Well, like half a volt more. Yeah, that's not gonna work. I wish it would. The tangent thing just wouldn't work.
We got a couple suggestions of putting something on the rotor until it falls off. I'm like, oh wait, maybe something that would spin. Get stuffed in. No, I'm just kidding. I know, I'm looking for it. You can see me looking for it, right?
Words, dude.
I found something. Can I put this on there?
Yeah, go ahead, man.
All right.
No, not like that.
Like what?
Put it on the side. Don't put it around the shaft.
Oh no, I don't want it to hit the coils.
Well, it's gonna. You just said until it spins off, so I don't know what you're doing.
Or a bolt. Do we have a bolt? Oh, a bobbin. That's not.
It's scooching right along. See, if you put it,
Yeah.
you got nothing. You got no action. You put it out here, it's just gonna scoot right up. No, we don't need anything heavy or metallic on these. Sorry, we're not gonna do that. We could do those iron cores. That's about as metallic as we're gonna get, though.
I think we might make some shorts. We used to make shorts where we were having weird things spin on it. Yeah. Or we should plan. We should plan some items for that on a live. Oh, nice. It got locked into the
Oh, it is locked in, isn't it?
to the magnet.
Yeah, it's magnetic. It's locked. That's sweet. All right. And then you got your standard splitter. I've had this for 20 years.
That was a nice one. He said, put it on when it's off and then raise the volt until it flies off.
Oh, it wouldn't take many volts. Oh, you're talking about magnetically attached? No. Magnetically
my bad.
attached? And then spin it until it flies off? You realize what kind of projectile?
No, like a plastic something, like a stuffed animal or something.
Oh, I thought you meant like a bolt.
Yeah.
Or something that would be magnetically attached. It would take a lot of inertia to actually whip off. We're not doing that. All right.
We gotta find like a small one that would fit on the inner part of that 8-inch rotor.
Yeah, don't go looking around.
I won't. I have an idea. I saw one at a place just the other day.
All right, so I'm gonna place these back on.
Oh yeah, check this out. Try to get a wide view. And then we'll explain what we're doing here.
Well, I mean, that bearing is stuck.
Oh, right here, you want me to try?
No, I mean, it's stuck.
Oh, that's the shaft moving, I see. All right. I gotcha.
So it's it's not perfectly level. I'm gonna redo the whole base of this thing. I'm just getting measurements, I guess you could say. Never had this much trouble with the tree before. So I need to make a design for the next 2 discs that'll interact with the top of these 2 discs. So these are the magnets that I've chosen to use, right? Right here.
He said that is that.
That's a good one. No sacrilege, man, in the chat. Come
Yeah.
I'm borderline on wasting energy, but it's all in good fun.
Yeah. Learning. Passion.
Definitely learning on how not to do so. And in the process, it'll become abundant and relatively inexpensive, quote unquote, free for everyone. Not just the people that know how to mess around with electricity.
Over capacity.
All we need to avoid is an apocalyptic war that will wipe out the grid. We need to avoid that.
Yeah.
And I think,
Ooh, do the three wheels spin each other?
yes, they do. We can spin from this side, and it'll all spin. Can spin. Go ahead, spin that one slowly. That one will spin all three. And I'll do the middle now. The middle will spin both, all three. But I want to talk about the next layer.
Okay. I'll try to be right here so you can show the levels.
Tell them how it is, man. Well, this is how it's going to be. Right here. We'll have our traction, and then here we're going to make it interact with the top of this disc like this one interacts with this one. So I believe the next one's going to have 12 on it instead of 6, and it's going to kind of try to interlock with the top like this one interlocks with this one using this right here. So it's gonna, and mind you, this is in reverse. I'm not trying to push all three of these with the top disc. I'm trying to have all three of these push the top disc, the opposite of what's going on right here. So I believe there'll be enough connection between the two discs to have this one be moved, because we're going to step up. We're going to go up to here and over. So I know I got to print the next one for it to actually be there, and then we'll go alternating. So every other one will push and pull. You get what I'm trying to say? If not, let me know. So the next one that I do won't like be on the ground over here on the same level. I'm going to step up. You go around like that.
Yeah. What was the inspiration for the design?
Genomes.
Yeah.
Double helix was an inspiration. I'm not saying I'm doing a double helix, but it is an inspiration for this.
Did you want to turn that one on?
Yeah, so what I gotta do now, this one is a double north-south being run on a trigger coil, and what is it? So I gotta turn it up to basically 16 for it to function. Maybe 12. I could do 12. I don't think 12 though. I tried to run it on 12, but runs on 12 sometimes. Really got to jack it up to like 16 for it to even work. So that's what we're going to do.
Nice. Hey, Woodsy, yes, he uses Tinkercad and the splicer. Eddy,
Slicer.
the slicer, excuse me, and then he eyeballs a lot of it, so he's been doing excellent.
Right. Well, I do what I can with the limitation of my tools. You are about your tools, man. That's all I gotta say.
Straight up.
Yeah, I know about the bad 3D printers. But yeah, I know about that. It sucks, man, because you know you went and you spent that money on it, and then it's like it's so fragile sometimes. Sometimes it is. It's fragile. I'm really grateful that the ender that I got is working so well and continues to work. But what's really important for the printers is if they have a little clip that you can put the wire in, use that clip. It's there for a reason. Don't think there's a piece of this thing that you shouldn't use. It's all for a reason, and you don't want to find out what some of these reasons are. You really don't.
We got a request to cut the power off and time how long it takes to stop.
Okay, that's a good. You gonna time it?
Yeah, I'll look up here.
All right, on your mark, get set, go. And off.
What's up, Splash?
How's it going, Splash?
And we got some action.
Ah, nice. Yeah, if I didn't have those, if the 6-inch discs weren't there, that thing would be spinning
1 minute.
for a very long time.
1 minute, 5 seconds.
Yep, and then turn the other way. So, I was thinking about this other pulse motor that I was planning on building, and now that we've got proof of concept for the eddy currents on permanent magnets, we can use permanent magnets.
Yeah.
And that's going to widen possibilities for that pulse motor. So 1 minute, 5 seconds. I'm pretty sure that is a world record. I'd have never seen anything like this. I heard that Howard Johnson may have built something like this.
The shaft.
Look at me, man. Do I look like I know how to test the flux? I know that these poles are very magnetic, extremely magnetic. The long ones, anyway. flux capacitor.
Yeah.
When we reach 88 miles per hour, you're going to see some serious.
So you want to?
Yeah, that one, the slow rewind, not the real fast one, but the slow one.
Nice.
All right, what's up?
You want to explain the setup one more time here?
All right. So in the middle, you got a north-south arrangement, alternating magnets, and then on this side you got all north facing. So you get an attraction and a repulsion, attraction, repulsion, attraction, repulsion. As a matter of fact, I think these are all, they all end up attracting. But at the same time, no, I had it right. So it goes north-south, and then the north attracts, and then the south pushes the in-between part. And then here, you got, these are all south. So you never have a double load on the middle rotor, okay? Here is attracting, and then on the 180 degrees are going to be the same, north. This is repelling, okay? So you never have a double attraction on the rotor. You got a double attraction on the rotor, it's going to stop.
So this is an interesting one.
No, which one?
Reposition it so it's in a triangle instead of a line.
Oh, I've done that too. I mean, we got Mickey Mouse, we got tricyclicon.
Oh yeah.
I've done that.
Mhm.
And that's not what this is, man. This is totally 100%
Foundation for the sculpture.
foundation for the helix sculpture.
Mhm.
And I'll probably do another tricyclicon. I think that's how you say it, right? It's basically the three twisters. They're all spinning in the same direction.
Oh yeah.
Thanks, Brian. It might be interesting to see that, but I'm not doing that right now. Might do that after we. No, I will have to do another build for that.
Do you remember what happened when you did the tricyclicon? When they interacted with each other that way?
Not really. I'd have to do it again, and all those discs have to be the same size in that particular build, not in different sizes. They don't all have to be the same disc, like magnet arrangement, but they gotta be the same size. Or you got Mickey Mouse, straight up. But you mean in an isosceles triangle, right? Is that right? Or is it? It's the triangle that goes like this, right? Where?
Oh man, trigonometry. He said yes.
Okay, yeah, I understand. Yeah, those angles won't work with the discs.
Oh, the different diameters.
Right.
Yes, Splash. That's the we are planning for that. Yes.
That's how we're doing it, Splash. And I have I built a prototype like 3 years ago of an actually complete one with wooden discs on wooden poles, and it was neat. It's really neat because there's actually going to be 4 steps and that are going to connect on their adjacent poles. So this disc is going to come around this way, and this disc is going to come around this way. And they're going to be right here. Now you can either put another middle disc up here and have it be like another segment to match each other, but I'm not going to do that. And if they all spin, that'll be freaking awesome. Because that's 1, 2, 3 for the bottom layer, and then 2, 4, 6, 8, 10 more. So 13 discs that'll have to be moving on just magnetic coupling. So I don't know. Off 1 rotor, sir.
Yep, off the foundational.
Now I managed to get 8 discs to spin off of 1 motor. There's a DC motor. Just like this. And I got 8 of them to spin. But I'm using a pulse motor. I haven't even attempted that yet. I didn't know how to build a pulse motor when I built my first one. Yeah, I know. In order to have what's in my head come out, I need a lot of discs. And I really like how these couple. I love how they couple. They couple greatly. It is truly miraculous. I can spin it at any speed basically, and they'll eventually sync if they don't sync automatically. And that was me like really whipping it kind of strong. It's like for what it is, it's a perfect interaction between the two. Actually, between the 3. Because like I said, when this one's on, this one's off. So that the middle rotor doesn't always get bogged down with the 2 being on at the same time.
Thank you, Noah. Have a great night.
Thanks, Noah. Yeah, when I get to the height that I want it to be, I might shorten the rods if I can find a saw that'll cut them. So the fluidity of motion between them all is so cool. Thank you so much, man. I agree. Splash. I totally feel it. And I've been struggling with this for 3 years on just a setup that would work. And then it's weird how it happened. I was trying to put these north-south, and they all kind of just right on my hand.
Dude.
So I was like, no, I'm not even going to try that again. I'm not even going to try it. I don't care. If there's a mystical, magical, engineering way to make it work, I'm not interested. That's how I felt about it. So what I did was I lessened the strength of the magnet. So I used these smaller magnets that weren't as strong, but they're strong. They're N52s. They're just nowhere near as strong as the cubes. So I mean, they're strong, but then again, they're not strong. And then I got the north-south configuration in to a rotor finally, which was just awesome for me. It works really well on the coil that I use, and it's the only way that I could make them couple with these discs as well as I do.
Awesome, Woodsy. Thanks. Welcome to the fam.
Thanks, Woodsy. Now, what I really do appreciate is people that have an idea and have the wherewithal and the time and the money to maybe manifest that idea to actually give it a shot. Right.
Hey, Patrick. Welcome to the channel.
I mean, you can throw your ideas my way, and I can definitely, like the tricyclocon design. I dig it, man, and I'm gonna try that. But you know, that's my point. If you got an idea, drop it. But if you also have the time, money, and you know, like I said, just you can do some of it on your own, man. Go for it, and post a video. I can almost guarantee the FBI is not after you today.
Hey, Bob. This is a foundation layer of a pulse motor sculpture, and we're gonna bring it up levels and twist it around.
So the next disc is going to be a 12 slotted disc. It's 6 inches, and it'll couple with this disc on top of it. Oh, you know what? Oh no. Alright, so this sculpture has gone through many iterations. This was like one of the first ones.
Nice. Yeah. Jolly Roger.
So it's virtually going to go like this. And it's going to get pushed by the system here. Boom, boom, boom. You see how that'll work? I think it'll go this way. You can imagine a pole going through the center of this thing, and it'll go around the pole. Okay?
Mm-hmm.
I think we all get how it's going to work. But this is the 12 magnet design for the 6-inch disc that I'm going to do. See how that interacts?
Let me try to get it from this back angle.
You gotta get it from the top, man.
Got it. Oh yeah.
So, like, it's on right there.
Oh yeah, dude, that's wicked. It's moving the whole thing just by messing with the field.
Yeah.
Splashed it good a second ago here. It ain't about the size of the magnet, it's how you use the magnetic field it outputs. Bam.
Alright, so who wants to see the aluminum disc spin?
Oh yeah. Oh yeah.
But yeah, we'll probably shorten the length of the poles by about a foot. By about a foot.
Yeah. Hey everybody, welcome to the channel. Thank you for dropping in this evening. Drop us a like and subscribe. Let us know if you guys have any comments about what we're doing. And thank you once again for coming in.
Thank you.
You think you can just hold?
I'm not holding it.
Oh yeah, that's right. And I'll shake.
Oh.
Finger, sorry. Oh, there's bearings in there. Yep. With eddy currents.
Man,
That one closest came out.
nothing came out, dude, but this is very not fun. Setting this up.
As a stand.
Yeah.
Yeah.
Really just not fun. Alright. Actually, I kind of want to line it up. There we go. Well, let's just see if it's working. You let me. Oh yeah. Alright. Now I'm gonna see, because last time the motor wouldn't run. Actually, we're gonna make sure that it runs.
Thanks. I'm gonna do this upside down.
Alright. Sweet, sweet, careful.
16.
I'm gonna let it juice up a little bit. Yeah, man. When I just said let's tone it down a little bit, and I got the north-south built. Yeah, dude, it opened up a whole new can of worms.
No doubt.
And I believe as it spins, I believe the shaft is spinning too. Yeah, it was. The shaft is moving. Heck yeah, man. Woo, we could put a fan on the back here.
Wow.
But the rotor's spinning in the bearings and the shaft is spinning. So it's like every time the rotor bearings grip the pole, it'll, spin with the rotor. Because the bearings must have some stickiness to them or something.
Yeah, that is spinning. Wow.
Yeah. And
What?
this aluminum disc is whipping.
Yeah.
You gotta go around the other side. And get
To
a
see,
better
because you
view.
can't see the tape on it anymore. Yeah.
Heck yeah.
I like that. Drop a like if you like that.
Haha. It's a nice aluminum disc though. See, now what I could do with this, instead of cutting out, you know, wedges of this, just wrap it around the outside of the rotor itself. And see if we can get some eddy current to spin it.
Alright. Yeah, you saw that.
Alright, man, I gotta use the restroom. I don't have my mic, just make sure it doesn't fall off.
I just got it off because it started shaking.
Hell yeah. Oh, you turned it off?
Yeah, started shaking. Can you move that back? Oh no, I guess that would be right.
Somehow the bearings got moved out, so I'm just gonna move this off. I don't wanna mess with that right now. Alright. So, I think that's all pretty cool stuff. So I'm gonna hook this low voltage thing back up again. And the switch is made out of 18 gauge and 14 gauge. So when it hits, man, all the amps in the world can flow through it.
Yeah, it did splash.
You know? Did anybody get a count on this? All right.
Good point. That's definitely a lot longer.
Oh.
Have you heard this word before, bro? The bearings must be fixed with.
What is that? I have no idea what that is.
We'll look at that, Patrick. We haven't heard that one before.
I don't read much. Pretty prejudiced, actually, against the written word.
Your work is very great. It's a German word. My English is not so good.
Yeah, it's just that it can be so easily manipulated and controlled. The written word is like math, man-made. But there are like universal things that are not, that are just discoveries.
Holds its bearings in position.
Yes.
It's a type of retaining ring.
Yeah, yeah. I used a spacer, but there's obviously a better ring for it. They're not here. They're in here though. The metal right there. The bearings fit right in there, but they don't. They slide in and out. It's too big.
Okay.
In other words, it doesn't function the way it was meant to.
Oop, finger, sorry. Thank you for dropping in. Have a good rest of the day.
Thank you.
Okay, cool.
Oh, like a gasket.
Yeah, we're gonna check that out. Thank you for that, Patrick.
It's like a gasket for this stuff. I got you. I have some 100-volt, 1 amp reed switches on the way. They're like this big. Really cool. It cost me like $10. So I said, what the hell?
Do it. You want to talk about this one more time?
Oh, the axial flux coil. Is this? I have questions about this. You know, this is 22 gauge wire. It's about 70 turns. And I need to make 4 more of these, as far as I know. And then you lay them on the table like so. 3 flat out like this, and then 2 on it like that.
Yeah.
And it makes your north-south configuration segment. So you can do that all the way around the freaking motor like this, but this is just a segment of it. And then I need a switcher, like to switch the coils from north to south. A polarity switcher. I don't even know if you can like buy one of those. I think you have to actually make one of those. But I don't know. I literally, I don't know. I just know that in order to move the aluminum, you have to have an alternating polarity. At least. That's one thing you need. And And since I have 26 gauge too, so if I'm making the coils too fat, could somebody let me know, like right now? That'd be awesome. But I heard the high frequency needs a kind of fat gauge, 22 gauge, 20 gauge, to function correctly, to flow through. You need some current, you need some frequency, you need some copper for it to flow through. Awesome. And yeah, to have the poles be smaller would be great, but they need to be at least this high, because it needs to be that high. The one in the middle can be short. All right.
So when you say you don't know how much is a guess, and is it like the work that you're preparing to do to figure out in your head?
What are you talking about? Speculation? I don't speculate really. It's all what I've heard. I'm not saying all of it is necessarily accurate. And when you say what I say, you got to be more specific than that, because I've said a lot. If you're talking about the coil that I was just talking about, I heard about this on somebody's YouTube channel. So I don't know.
Yeah, those ones.
This coil. Oh, I know that there's a lot that I'm missing. I know that one of the pieces is that you have to have alternating north and south. And
the polarizer.
I don't know what you're talking about.
You would have to buy one, or you would have to make it. You were talking about a polarizer.
Oh yeah. Oh right. Absolutely. Yes. I figured that it was a polarizer of some kind. And the schematic that he had for this thing was freaking unimaginable, dude. It's like a maze of freaking transistors and capacitors. Just unbelievable stuff. So if I could buy one, that'd be better for me. But yeah, there's going to be 5 coils. Man, I should probably be talking about this more when I have the coils all done.
Okay, right.
But kind of like the Olympic rings, except stacked right on top of each other.
Right, I see that. Mechanical.
Oh yeah, no. Actually, mechanical engineer is exactly who I wanted to talk to. I was thinking about a piston, a magnetic piston though, that would function on a rotor such as this, but go all the way around the rotor like small pistons. So when you spun the rotor, the pistons would function, and maybe it would continue to move, maybe not forever, but for an elongated period of time, just on the pistons pumping back and forth. But I mean, those pistons would have to be super, like, greasy. Yeah, man. If we could develop a piston that could prolong magnetic movement, like an actual, so people don't freak out, you know, like, oh my God, it's a car that works on permanent magnets alone. Who would have thought that? And you don't need any electricity whatsoever. I know that sounds crazy, but I think it's totally possible if that piston idea would work. You know, the piston pushes the wheel pushes the piston, but it's happening at a rate of like 12 or 13x.
What's up, Mike?
Hey, Mike. Yes, exactly. The outer ring, man. That's all pistons. Yes, and they're in sync. Like my two discs are in sync with this rotor. The pistons would be in sync with the rotor. Yes. Wow. Right there, man. And why can't it have the same functionality as a regular piston? I mean, a regular piston does combustion, but I mean, yeah, I don't know. Just to get it to work would be awesome, and then its practicality can come later.
Whoops, finger, sorry.
Hang in there, bro.
I'm good. I keep on getting my finger in the shot.
Mike, check this out. Axial flux cable. Our coil. It's a 22 gauge coil. I think that might be a little strong. Yeah, stator wind for moving aluminum. Yes, yes, man. I had like a daydream actually about this thing, and it was awesome. I'm like, yes, they can. Yes, you build it this way. I didn't know what I was talking about really, but I'm like, look, if you just see, and if these things move like really, really good, it'll move. Might not move forever because eventually they're gonna get stuck or sticky or whatever. But it should, like, you know, move itself, which is basically what the whole thing is. Can it move itself? Can it charge itself? Can it self-sustain? I mean, human beings can't even do that.
Oh yeah, Splash said, couldn't you put a piston arm on the aluminum disc up into a piston chamber? Yeah. Yeah.
Yeah, I'm pretty sure we could. That would be awesome.
Mm-hmm.
Hold on, go back up, bro.
Yep.
Right there, right there. Down a little bit, get that arrow out of the way. Stator there for power pickup and generation. Well, yeah, it is, but what I'm trying to say is that it's not going to be moving. When I say stator, it means it's going to be still. So that's just, maybe it's something wrong in my head.
Well, no, it's more of a like a hairpin setup. Just
It's definitely going to be a drive circuit though. It's going to switch North Pole, South Pole. It's not necessarily going to be a standard axial flux build. It's not. It's just a segment. I'm just building, 1, 2, 3, 4, 5, and then seeing what I can do with that. Just the simplest segment of the motor.
Oh yeah, the hairpin came out of the automobile industry, for sure.
Yeah, there were a lot of coils in the actual axial flux motor that I didn't understand. I'm just using the standard drive configuration that you can move around. You know, you can move it from application to application just by moving the coils. It's not necessarily in any configuration. You can even do, see, the thing is, I don't think I can do radial flux with this coil. It's really stiff.
Yes. Yes, it would. Yeah, I can envision that splash. That would look cool. Oh, I got it. Look, I got it. There he is. He's back.
Right, so, but this is 22 gauge. I have a roll of 26. Should I make these coils in 26 gauge, or is 22 gauge going to be good? Because I'm looking to run a frequency through it of about 500 to 1,000 hertz.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale.
Hey,
We are working with pulse motors this evening and discussing some future designs and experiments. Let us know if you have any questions.
I think I'm in, well, whatever works better with the higher frequencies, I'm going to probably have to go with that one. Well, I want to get a pizza.
Yeah.
I've only checked it once.
Easter. That was funny.
I seriously have only looked at the watch one time though. It's awesome that he caught that.
Yeah, heck yeah.
And then if I've looked at it more than once, my memory is not good. Not good. Alright, so this is 5 volts in.
See if I can get a close up on the switch. See the arc there. You guys see the arc? Kind of just see the flash.
So that's a parallel reed switch circuit over there. I didn't think those things were possible. And then I'm like, well, if I connect this and this and this and this, and then my reed switch makes it really easy because it's got ends like that. You just clip a bunch of coils to it and then clip the one end to the ground, and there you go. And they're all timed right too. It's awesome.
I'm starting to think of it like a water pipe at this point. When the way you're talking about the way you talk about it, the way Mike talks about it. So more feet translates to more turns.
Yeah.
And then same feet, same turns.
Okay.
And then to push more through.
Yeah, I know the standard, about thicker, you can push more amps through. It has a higher max, current. You can handle more current. But I'm really just worried about the frequency because both 26 and 22 can both handle the current and the voltage. I'm just looking at what's going to handle the frequency better. So I think I'm on the right track with the 22 gauge. And I'm going to use, well, now let's think, man. I'm going to use probably about 50 to 60 volts.
So.
But I can change the ohms with a resistor, correct?
And splash, I would think so with the correct setup, because I know that chemistry labs use magnetic spin.
That's awesome. And I haven't got the edges, the tips ready for this one yet, but I should definitely test the ohms, Mike. Because this one's going to be killer. I think it needs a little bit more resistance, honestly. Yeah. Yep. And I'm thinking this one's going to be probably right around 10 ohms. All right, I'll be right back.
Rock and roll.
Ask him about lens wire.
Hey, Mike, you know anything about lens wire? How many volts are you going to give the 10 ohm coil?
I would be 50. Well, there's going to be 4 more of the coils, but eventually I'm going to put 50 to 60 volts through it.
Yeah, Mike, that's it.
Oh yeah, we're over here.
So 40 ohms, 4 coils, 10 ohms each, or 5 coils?
5 coils.
So 50 altogether. Are they?
I was guessing though. Let's see what we got for real here.
Are they in series?
1.3 ohms.
Okay.
So this coil is not anywhere near large enough. So I think I'm going to have to go 26 gauge. That is 1.3 ohms. So that'll be 5 ohms altogether. Oh man. So it's going to be like 10 amps. 10 amps because it's 1 ohm actually. No, I mean I know yours means that, but that's not what this is. Wow. I like the equation though. I'll try and remember that. It's proportionate.
Welcome to the channel, Josh.
I just showed you the ohms on this thing. I just showed that to you. I know I probably can't use this, but I mean,
Yeah,
I just showed you the ohms, man. 1.3.
1.3.
22 gauge.
Did you know how many feet it might be?
I'm thinking it's 25. 25 feet. I literally just take this. It's about a 3/4 of a foot. Yeah, 5 of them. I'm probably gonna have to redo this because that's insane. That's gonna this is hellfire and brimstone, man. Yep.
Oh, the cover. Yeah, we did.
50 volts across 6.5 ohms. Dang.
I'm not sure. I think we may have taken it already to the storage unit. Oh no, I think I see it.
Yep. I'm coming up with a blank. It's gonna be less than 10. So it's gonna be about 8.3. No, I'm just kidding. Huh. What are you looking for?
This right here.
It's no, don't put that on there.
I'm not gonna.
Okay. I consider that to be one of my failures. You're supposed to catch wind. Yeah, that seems about right. And then the frequency we jack up to about 500 or 1,000 hertz.
380 watts. So. Yeah, the wind wouldn't go into the shafts that we built for it.
I got a 480. That's about as good as it's gonna get. I have two 480s. Don't have a 500.
Right, and then we built the second one.
No, the other one's the first one.
Oh, the first one. This is the next design.
First one.
Excuse me, the first design. And we're gonna, iterate on that one. We are in the United States.
An FET. So what's an FET stand for, Mike? I would love to get a transistor that will be able to do that.
Field effect transistor.
Field effect transistor. That seems like it's going to be my new best friend.
Okay.
Yeah, I know. I know.
I don't think the FETs do high frequency though.
So which one do I need for high frequency? Like a MOSFET, right? Because I got this signal generator and I've been messing around with it, and I've been shooting, 500,000 frequency through this coil right here. And I've also had the trigger hooked up to it, so it would trigger and then it would hit. And every time it hit, it'd have a frequency of 500, 550, and they go, like that. I don't know how to read those things, Mike. I have no idea what that means. All that stuff on there. What I do is I just hook the signal generator up to the base and the ground, and I start at 1 hertz. That's where I start at. Ha. Come on, we're all learning here. I think we're all learning. I'm learning.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale.
Hey, what's up?
We are working with Pulse Motors this evening. Learning from the community. We have a great moderator on board right now, Mike does. Feel free to ask any questions and drop a like and subscribe.
Oh. Alright, so we're going to end up, I'm going to wrap it up here pretty soon. Because I need to relax, sit down,
Get some pizza.
and get some pizza. Yeah, it's a 1-900 number. Consultations will be starting at $2.88 a minute.
Per minute.
I love the little quote-unquote Bedini coils, though. They're sweet. But you know why it's not a Bedini coil? Because it's only got 911 turns in it. So it's an M.P.H coil or a Papa Bale coil.
Papa Bale.
Heck yeah, man. We're going to get some dominoes. It's the only local restaurant we got.
True that. Oh, nice. You can hear that through the phone clear.
Sorry, Mike. Way to go, though, man. Putting pizza off for 2 years, man. That's an accomplishment. Or a year. You know.
Yeah, it is.
That's,
Holy
that's
wow.
still a big deal, man. Oh,
Metro Detroit.
yeah, the fourth most foul mouth place in the world, I think. Something like that. Well, it's the fourth most foul mouth place in the United States, and I'm pretty sure we capitalize in the world on how potty mouth we can be.
What's up?
What's up? Definitely from the east side of Detroit.
Good. Yeah. 222 watching.
Nah, I mean, like, we live just outside of the populated area, but we are close, man. We could, like, literally walk, go shopping, come back, all in a day.
Mm. Boston in the house.
Boston. Got family in Boston. Got a friend lives in Boston.
Mm-hmm. Nice. Maine in the house.
I'm digging your avatar there, PWFV.
Yeah. Big
Digging
time.
that avatar.
Nice. Indiana in the house.
Oh, bringing people together. Here we go.
Mm-hmm.
That's awesome. We got like a whole spread tonight. Yeah. I dig the whole secret society thing. Yeah. The G. I don't know too much about it, but I definitely vibe with that. So that's a square and a sextant, right? Or for like navigation and well, no, that one thing is for drawing circles. So it's like a protractor.
Oh man.
Square and a compass. That's it. The compass. Fuck. Man, sorry. That's the second time tonight, and I apologize for those people who have to do extra work because of my mouth.
Thanks for that, Mike. Pennsylvania in the house.
Yeah, maybe I relaxed a little bit too much today. And I just square and a compass. That's it.
Proper tools.
Oh yeah, the compass has gotten me through a lot of things before I had my 3D printer. Yeah, I heard you. Where's my remote? There it is. There it is.
All right, the phone is at 2%.
You need to set up the smart view.
It's all right. I'll get it. Yeah, we're good. We got 188 on. I just did it, and then I went back because you were asked if we were on. So let me go back there. Let's see if that.
Wow, man. And only in this day and age can you come back from your phone actually dying 100% and then come back to your live stream and have it not be totally dissolved. That is amazing. Thank you all. So I just came back to basically to close out because
Yeah, 1%. You gotta go.
So thank you very much, everybody. I do appreciate you sticking around, but I do want to get that pizza real fast. All right. Good night. Thank you so much. I just had to come back and make it right because it did die. And bye now.